Hello everyone and welcome to this amazing session at PW. My name is Aman, your favorite maths buddy. Today I'm coming again back to revise the new chapter which we had already done, that is polynomials. Now this chapter is much more conceptual than the previous one and you will be enjoying the very basic concept in case you have missed. So make sure that you have the notebook in front of you and you note down the key concept today. So what are we going to revise in today's chapter? In today's chapter, first thing we'll be talking about is what are polynomials. We are going to talk about the classification of polynomials. Where does polynomials come from? How are they different from algebraic expressions? Then we are going to talk about the zeros of polynomial. How do we find the values of a polynomial? And what is the method to find the zero? That is the important thing. Important chapter, important concept, this one. Then we are going to talk about the specific concept of polynomial, that is quadratic. Our focus in this chapter is on quadratic. And in quadratic also we are going to talk about a particular thing which is relation of the coefficients with the zeros of a polynomial. These two topics in this chapter are the key concept. If you know these two topics, then you know this chapter because majority of the question come from these two topics. So I hope you are excited just like me and you have the notebook and you have the same zeal to learn in today's session. Even if you know most of the concept, then don't worry, it's a revision session. You will be revising all the concept today. So on that note, why waste more time? Let's start the session. So to start the session, first thing first, we are talking about polynomials. Now, this polynomial is related to algebra. What is algebra? Now, most of the time we come across things which are unknown to us. In our real life, there are many places where things unknown to us. And in mathematics, we say them by the name of variable. You must have seen in mathematics numbers like, not numbers exactly, variables like x, y, z. Or if you have your own favorite, you can use A, B, C. Like this, any of the alphabet, any of the letter you can use basically. So what are these? What are they doing in mathematics over here? In mathematics, they are just known by the name variable. And what exactly is variable? As the name suggests, variable. As the name suggests, variable. Basically, they can vary. They can have different values. X can be 1. It can be 2, it can be 3, it can be 0, it can be a negative number, it can be a fraction, it can be a decimal. So hence it is a variable. And in algebra, we deal with variable, or I would say unknown part. Now, in algebra, the first thing which comes up is the algebraic expression. What is algebraic expression? Algebraic expression is basically a relation between a variable and a constant with an operator in between. So new terms coming up. Now these are the very basic. If you don't know these basic, there is no means that you can understand polynomial. Now let us understand quickly. If I write expression over here, 2x plus 3. Now in this 2x plus 3, we need to understand few things. What are these? First of all, over here you can see 3. Now 3 is a normal number. You already know about 3. 3 is a normal number we regularly use. So 3 over here is called as a constant number. Constant, yes, as I told, we have a variable x which can have different values. Yes, it can have a value of 1, it can have a value of 0, it can have a value of 3 also. But 3 on its own will never change. It will always remain 3. So this over here, this 3 over here is a constant. This is a constant over here. It is a constant because the value remains constant always. Then I told you about variable. X over here is our variable. And the relation between the variable and the constant is algebraic expression. But how are they two interlinked? They two are interlinked using any operation. What operation? We have operation of addition over here. We have operation of addition over here. If you observe closely, we have one more operation going on. What is that operation? It's the mathematical operation I am talking about. The operation of multiplication. If you observe over here, I have written 2x. Now what is 2x? 2x is nothing but 2 multiplied with x. 2 multiplied with x. Don't get confused. Bigger x, smaller x. This is multiplication sign over here. When we have a multiplication sign in between the variable and the constant. So the constant value over here is called as the coefficient. It is called as the coefficient. If someone asks what is the coefficient of x? The coefficient of x over here is 2. So what we have talked about till now? We have talked about variable, we have talked about constant, we have talked about operator, we have talked about coefficients, all these things. Now, such kind of expression is known as algebraic expression. Such kind of expression is known as algebraic expression. But another thing which we come up is algebraic equation. Now, equation, use equal. So wherever we have this term equal, 2x plus 3 equals to 1. Now, in this case, 2x plus 3 equals to 1 will be called as the equation. Why equation? Because we have a equal to sign in between, just like that. Alright, so this is the difference between algebraic expression and algebraic equation. Fine. Now, but our chapter name is polynomial. Why are we emphasizing so much on algebraic expression? Now, let me first show you the definition of polynomial, and you have to comprehend how polynomial can be different from algebraic expression. So, this is the definition of polynomial. Let me read it out for you. I hope you can also do the same. It's written over here, polynomial is an expression. Now, expression relates to the algebraic part. Expression consisting of a variables and coefficients. Variable and coefficient. This is exactly what we learned in algebraic expression. That involves only operations of addition, subtraction, multiplication, and a whole number exponent. Over here, if you observe, the only difference is the additional line over here and a whole number in bracket non-negative exponent. Non-negative exponent. First of all, what is exponent over here? Now, you must have come across numbers like x square, x cube, x raised to the power 4. Now, these value over here, 2, 3, 4. These are exponents. These are exponent. There is a chapter by the name of powers and exponent. Now, if you haven't learned yet, you will be learning in the upcoming time. But you should have a basic understanding where we are having a superscript 2, 3, 4. These are the exponent over here. Alright. Now, they are talking about the exponent that it should be a whole number. I hope you remember the previous chapter where we talked about the difference between a natural and a whole number. Now, a whole number first of all starts from 0. So, 0 power would be fine. It will be satisfying our given definition over here. But if we have a negative number, will that work? I hope you understand that negative number is an integer. It's not a whole number. So, if I say x raised to the power minus 2, will that work for me? Will that work for me? Going by the definition, it will never work for me because that's entirely wrong. I want a whole number. I want a whole number. Other than that, if I write a fraction, if I write over here x raised to the power 1 by 2, 1 by 2. What about this one? Again the same case. Is it a whole number? No, it's not a whole number, it's a rational number. The difference between whole and rational number. I must have told you about the bigger bag, bigger bag, bigger bag. So, the smallest bag is the natural numbers, then we have whole numbers, then we have integers, and finally we have rational number. So, rational number is the biggest bag, but whole number part, 1 by 2 cannot be a whole number, it's not intact. 1, 2, 3, these numbers are whole number. So, again, we have a number which is not a polynomial, expression which is not a polynomial. So basically I am saying whatever power is there on the variable, it should always be a whole number, always be a whole number. Things like this will not work. So if I have to write, let me write the expressions over here. 2x square plus 4x plus 3. Does it go well with our definition of polynomial? Yes, it works very well. Why? Because we have a power of x. Over here we have a power of x as 2. This is clearly visible. But one thing most of the students might miss is x is having power 1 in the second term. Now this is one term, this is second term, this is the third term. Over here we have a power of 1. Over here we have a power of 1. So over here the highest power is 2. But important thing to realize over here that there is all the powers are whole number. So that works well and hence it is our polynomial. But if I make a slight change over here and write 2 upon x square plus 4x plus 3. What happens in this case? To better understand this case, you should be very clear about few concepts of exponent. Like what? Listen very carefully because this is a thing which you will already learn or you might learn in the upcoming chapters. What are these? If I write a term like this, square root of x, You must be knowing square root at least. This is a very basic thing. Square root of x. How can I write in terms of power? How can I write in terms of power? So over here, I'll write in this form. This is a square root, square root. So square root is just opposite of square. Exact reverse operation of square. So square is x square, right? So over here, I'll write it as x raised to the power 1 by 2. X raised to the power 1 by 2. If I write cube root, I hope you know cube root, cube root. So basically cube is what? X cube. So I'll write in terms of power as x raised to the power 1 by 3. 1 by 3. Next concept. If I write over here 1 upon x, 1 upon x. Now, x over here is the denominator. If I want to bring it in the numerator, what will happen? In the numerator, I'll write it as x raised to the power minus 1. X raised to the power minus 1. 1 upon x square. In this case, I'll write it as x raised to the power minus 2. So, why are we learning exponent? We came here to revise the chapter of polynomials. If you don't know these concepts, you might end up saying a wrong expression as polynomial. Because this concept will help you realize which is a polynomial and which is not. Make sure if you have a whole fraction like this, that the expression given to you will never be a polynomial. Or a negative number in the power will or not be a polynomial. So this is how we need to recognize what are polynomials and what are not. I hope you have taken note of this particular definition over here. And most importantly, this line. Sorry. So this was the important part about what are polynomial, and the concept I have told you over here. This is the most important concept to understand whether the given expression is polynomial or not. Alright. One more thing I want to talk about in polynomial. What is that, sir? Now, I might say it is written like this, simply 1. I have written 1. Is it a polynomial, sir? Is it a polynomial? Now, few students might say, sir, polynomials would have a variable like x, y, z, a, b, c, m, n, o, p, q, r. But we don't have any of these. I would say, if you observe carefully, if I write 1, 2, 3, 4, or even a negative number, in all of these numbers we have a variable. It's not visible to you because you haven't learned exponents. Now, if you would have learned exponents, you would be aware. You would be aware about one important concept. What is that? If I say any number or any variable is having a power of 0, if any variable is having a power of 0, what happens to it? I can simply write it in the form of 1. X raised to the power 0 is equals to 1. So, is it working only for x? No, be it x, be it y, be it a, be it c, or any constant value. If I write 3 raised to the power 0, that will also become 1. So what's the point? The point over here is if I say 1, it is same as 1 into x raised to the power 0, 2 into x raised to the power 0, 3 into x raised to the power 0. I hope following this you can do on your own. The point over here is very simple, that any constant number is also having variable along with it. So it is a polynomial. Why? Because the power we are using over here is 0, and 0 I have told you is a part of whole numbers. So if we have been given any constant value, it will be also called as a polynomial, and we have a name for it. We call it as constant polynomial. Constant polynomial. So all these number 1, 2, 3, 4, 5 or a negative number, all these are constant polynomial. One specific number over here, that is 0. One specific number over here, that is 0. 0 is different kind of a polynomial. It is not as called as constant polynomial. We have a specific name because 0 is special in our number system. So over here we give it a name as 0 polynomial. 0 polynomial. Alright, so this is the important concept you need to learn over here. What we have learned? Algebraic expression, polynomials. Then we have talked about the 0 polynomial and constant polynomial. Now, since I am talking a lot about the powers, so there is an important term which is used in polynomial. What is that? That is the degree of polynomial. Degree? Some kind of a degree like we do as bachelors or masters, something like that. Something you can understand in this manner because the superscript. Basically, a person does well. In England, what they do, if person is of very high eminence, so what happens over there? They give them the degree of Sir. Sir, or any other particular name, knighthood basically they give. So over here, the power over here, the highest power of the variable is called as the degree of polynomial. The highest power of the variable is called as a degree. So when I write over here 2x square plus 3x plus 4, basically we have the variable x in this term and over here. Now the power is different. Over here the power is 2, over here the power is simply 1. Highest power 1 and 2. I hope you understand 2 is greater than 1. So highest power over here is 2, and hence I can say that the degree is 2. Degree is 2 over here. If I write over here 4x raised to the power 4 plus 4. A very simple term. In this case, we have only one variable x and it is having the highest power as 4. So the degree in this case would be 4. A very simple concept to understand. Degree equals to 4. And make sure always whenever you are checking a number is polynomial or not, make sure to simplify. If you are simplifying, then observe the final expression, because there might be some cancellation, there might be some division which might be happening. So you might miss out with the correct answer. So this is about the degree, highest degree of a polynomial. Now in degree, since I have talked about constant polynomial and zero polynomial, now this is a tricky part. If I say minus 4, what is the degree of this polynomial? First of all, should be clear in your head. Yes, this is a polynomial. But what is the degree of this number? For degree, I told you whenever we have a constant number, it is always being multiplied with a variable having a power of 0. Why? Because this expression x raised to the power 0 is nothing but 1. So 4 into 1, or over here minus 4 into 1 will give us the same answer as minus 4. So this number over here is a polynomial, constant polynomial, and the degree of this given polynomial is 0. So will it work for all the constant polynomials? You might think about this part. Yes, all the constant polynomials would be having a degree of 0. For constant polynomials, the degree will always be 0. Degree will always be 0, because that is the thing which is making them polynomials at the first place. So degree will be equal to 0. But a trickier part comes when someone asks you about the degree of a zero polynomial. So basically 0 is written over here. So what is the degree of this number? Degree basically is the power of a variable. Now when we have a number 0 being multiplied with anything, so it can be multiplied with x square. 0 can be multiplied with x raised to the power 3. It can be multiplied with x raised to the power 0. It can be multiplied with x raised to the power 100. Now what? We have 2, we have 3, we have 0, we have 100. So which among them will be considered as the degree? Why? Because 0 being multiplied with any of these numbers ultimately will give us the answer as 0. So which number we should consider them to be the degree? For this case, a clear understanding is that we cannot define, we cannot limit this part, and hence in this case we say that the degree is undefined. This is new term, I hope you understand. Undefined, we are not able to define it. Something is so vast on its own, we cannot define it. So we say it is undefined. Undefined. So two concepts we have learned over here. Degree of a constant polynomial is 0 and the degree of a zero polynomial is undefined. So that was all about degree. Now, since I am talking about degree, so the next concept also deals with degree. We have learned about the classification of different things. In the previous chapter, we did classify the number system. I gave you the example of Harry Potter. So over here also we are going to do the classification of polynomials. And the classification can be done on multiple bases. One important basis of doing the classification is degree. How degree? Degree simply because if you say the degree of a number, degree of an algebraic expression or a polynomial is 1, in that case you will say that the polynomial is linear. Linear. You can see the example over here. Simply x or 2y plus 4 or 3z plus 2. All these terms over here or the expression over here are having the power of a variable maximum or the highest is 1. So they are linear. Degree 1 being linear. Degree 2 is called as quadratic, and I already told we are more interested in quadratic polynomials today. We are going to talk about quadratic polynomial, degree being 2. So over here, if I write expression 2x square plus 4, the expression over here is having the highest power of variable as 2, and it is a quadratic one. Another example can be a big equation like 4y square plus 4y plus 2. This is again a quadratic one. The last one, I'll not elaborate further. I hope you can easily understand. Having a degree of 3 will be called as cubic. So linear, quadratic, cubic, and the sequence can go on, but you don't need to worry. These are the 3 names which you need to remember. This was about the classification based on degree. So what's the other thing on which we can classify the polynomial? Now, if you have observed till now, I have written polynomials of different nature. A simple one-term polynomial, a polynomial of 2 terms, a polynomial of 3 terms. So basically, I can change the term over here, and term becomes the basis of the next classification. So based on the terms, also we have the classification. If we have only one term, it is monomial. If we have 2 terms, bi, wherever we have 2, binoculars, 2, right? So bicycle, 2 wheels are making a bicycle. So wherever we have 2, we know it by the name of bi. All right, 3 will be tri. So in this manner, you can remember the classification based on the terms. Ultimately, if you realize the term polynomial, the name polynomial, how does it come? Polygons, basically a multiple sided figure. Poly is different, many, and normals over here is nothing but terms. So it can be 1 term, it can be 2 term, and it can be 3 term. Or it can be multiple. So in this manner, this word come up, polynomials. Finally, this is the summary of what I have told about the classification. Classification based on degree, we have constant, that is 0. I have talked about it already. We have linear, quadratic, cubic. And based on the terms, we have monomial, binomial, trinomial. And this table can go on. It's not that this is the last of it. It can go on, but we are interested in this much because this is our interest, because the question relates most of the time with this part. Alright. I hope you have taken the screenshot, and now is the time, since we have understood the very basics of polynomial, that we solve few of the questions. What questions? So here we have the first question which asks you about the given expression over here. This is a polynomial or algebraic expression, or you can say yeah, they are both. So what do you think about it? Whenever I come up with a question, always try that you pause the video and first answer. Then listen to me what's the correct answer. In this manner, you will be able to analyze whether you are going in correct direction or you need some rectification. Alright. In this one, we have one thing, 3 by x. If you have listened very carefully till now, so what I have told, if we have a term like this, 1 upon x, I can write this in a manner where x can come in the numerator. When x come in the numerator, the power of x will become negative. Whatever the power here it was simply 1. So now when you take in the numerator, the power will be converted into a negative 1. So 1 becomes minus 1. 1 upon x square. Here it becomes x raised to the power minus 2. So when I say 3 by x, it will be 3 into x raised to the power minus 1. If you have observed this part, if you are able to reach this step, then you are able to answer. Why? Because now I can rewrite it as 3x raised to the power minus 1 plus 2x plus 7. Now you can say that whether this is a algebraic expression or polynomial. One thing would be very clear, at least that this is not a polynomial. The reason, very simple, that we have a power which is negative in nature. It cannot be negative. So the next obvious question, sir, is it algebraic expression? Algebraic expression basically is a thing which relates the what two things, variable and constant. And yes, it doesn't matter whether we have a negative power or positive, it always do the relation. So yes, the correct answer in this case would be algebraic expression, option number B. So don't end up saying that none, or don't end up saying yes sir, polynomial. Alright, this is the case. Moving on to the next question over here, asking about the degree of the given polynomial. Degree of the given polynomial. Now, in this case, many of you would be very quick to answer. Sir, the power of x over here is 1, and hence I can say the correct answer is 1. Don't be in that hurry. The question has been formed in a manner where you might end up with a wrong answer. These two terms over here are in multiplication. What I told you when I was talking about polynomials, observing the polynomial, always do the simplification of the polynomial. This is not the simplified form. This is not the simplified form. If you have a multiplication, you need to multiply first. So few students might go the longer way. What they'll be doing? They'll be doing the multiplication of x with x, then x with 2. So basically opening up the brackets and doing the multiplication. A very wrong method. Few of the students who are having the analytical skill to understand and observe the given expression over here is a minus b and a plus b are in multiplication. I hope you remember the algebraic identity which you have learned in grade 7th. So that tells you over here that when these terms are multiplied, I can directly write it as a square minus b square. An identity which you can use over here and directly get to know what is the degree of the polynomial. Why? Because over here a is x, b is 2. So a square minus b square, x square minus 2 square. Let me write it over here. So it will be written as x square minus 4. This is the final expression for which you have to observe. This is the final expression for which you have to observe. Now tell what is the degree. Now, observing this one and this one are two entire different things. If you have gone through that one, you might end up saying 1. But now from this one, it's very obvious that the correct answer would be 2. This is a quadratic polynomial which we are going to talk today. Alright, so that was about polynomials, how to observe the degree of it. Always do the simplification. Next question, ask you again on the classification what kind of a polynomial it is. And it's checked for both. It's checked for the degree part as well as on the basis of terms. Over here, only minus 2 is written. So what is this p bracket x? This should be understood in this manner. Since we talk about polynomial and polynomial is having some variables, so whatever variable is involved, so I write that inside the bracket. P over here is signifying polynomials. Polynomial with a variable x. Polynomial with a variable of x equals to minus 2. So there is no x after equals to. How it is a polynomial of a variable x? You can always write it in this manner. I already told you x raised to the power 0. Right? Now, if we have this as 1, so it finally end up with minus 2 only. Now tell me how many terms are there? Terms? Only 1. Can I count it as the second term? Don't make this mistake. Term is always when we have a operation of addition and subtraction. Multiplication does not make two different terms, though both will be attached and will be counted as a single term. So one term. So we have option as monomial, monomial. What about the next? Degree. Degree we have already talked about the constant polynomial. Constant polynomial. Constant polynomial, I hope you remember. Linear, constant, constant. So finally, monomial and a constant having a power of 0. Option number B. So B is the favorite one. Most of the time we end up. One final question after which we move on to understand the concept of zeros. And this over here says about the classification again. What kind of a classification? Based on the terms, monomial, binomial, trinomial. So over here we are having 3 terms. So it's very obvious we are having 3 terms. So 3 means trinomial would be the answer. I told you, if we have been given some question, there might be a trick. You have to think about it. Read the options carefully, read the questions carefully. And when you read the question carefully, you might remember my terms, me saying that you have to always do the simplification. If you simplify this one, and you will observe that 4x and 3x are like terms. Like terms. The terms having same variable. When we have same variable, we can always do the addition or subtraction. So over here, 3x plus 4x would be directly added up, and the final expression we'll be getting is 2x square plus 3 plus 4 is 7. So 3 plus 4, 7, and this is our final expression. Now we can observe what kind of the polynomial is it. It is having 2 terms or is it having 3 terms? And the answer might be different if you observe this expression or this expression. So the correct answer again in this case would be trinomial. Trinomial. This is a mistake even a teacher can do. The correct answer in this case would be binomial. Alright, correct answer is binomial. I told you this would be the last question, but I want to bring up a very good question in front of you. The topic was what are polynomials? So last question will be about what are polynomials. So you have to observe the expression over here whether it is a polynomial or not. Now in this case, if you say, sir, it's not visible to me, so let me rewrite for you. This is written as x square plus 3x raised to the power 3 by 2 upon root of x. This will check all the concepts which I have told you till now. Why? Because you have to simplify the expression. This is the thing I am talking again and again in each of the questions. I hope you are observant of this fact. Pause the video and try to solve this one. I hope you have realized till now. In this case, we are having power as 3 by 2 and root x. I told you one important concept. Wherever we have root of x, I can always write in the form of powers. So x over here will be written as x raised to the power 1 by 2. X raised to the power 1 by 2. How does it help? It helps because I replace this part. I am solving only this expression over here. I am solving this expression over here. So I'll rewrite it as 3x raised to the power 3 by 2 divided by x raised to the power 1 by 2. Now, another important concept in exponent is when we have the two numbers having the same base and they are in division. So what happens with the power? The powers get subtracted. The powers get subtracted. If you don't remember, let me rewrite for you. We have x raised to the power a upon x raised to the power b. Two numbers are in division having the same base. In that case, the powers get subtracted. X will be a minus b. So hence, I'll do the same over here. When I'll do the same, it will be 3 into x raised to the power 3 by 2 minus 1 by 2. I'll leave it over here for you to solve and understand what happens. What happens when you do the calculation, it will come out what? 2 by 2. 2 by 2 will be cancelled out. We are getting 1. When we getting 1, so the power of the variable x over here is simply 1 and the final expression will be getting is 3x. This is not the final thing because we have to add with x square. So the highest power of x in this given expression will not be 1 but 2, and yes, both are whole number. Both are whole number, and when we have been asked about checking whether it's a polynomial or not. Now we will come up with the answer yes, which you might have not given in case you have just observed the expression and directly seeing that there is a square root on the variable part and seeing that it's not a polynomial. So don't commit such kind of a mistake. Be conscious about the basic concepts involved. So that was all about polynomials. We have spent a lot of time on the foundation of polynomials. Now we'll be more quick with the next concept, which will be dealing about the zeros of polynomial. Alright, moving on. The first thing over here is value of polynomial. Value of polynomial. If I write the expression 2x plus 1, it's a polynomial, right? Obvious thing we have already learned. Still you are not able to give me this answer. In that case, you need to pause the video and go back to understand what are polynomials. In this case, the value of polynomial, what does that mean? I told you x is a variable. So x is a variable. It can have different values. It can have 1, it can have 2, it can have 3. If I say put up the value of x as 2, if we have the value of x given as 2, so now we can find out the value of the given expression. What I need to do? Replace x with 2. Replace x with 2. So over here, solving this one, replacing x with 2. So 2 into 2. Why? Because the value of x is 2 plus 1. 2 into 2 is 4 plus 1, and final answer over here is 5. This 5 over here is the value of polynomial when x is equals to 2. It can change. The value of polynomial is not a constant thing because it depends on the value of the variable. If the value of the variable is changing, the value of the polynomial will also change. So you can now find out what will be the value of polynomial if we have x as 3 and if we have x as minus 3. So something you need to do. Everything should not be spoon-fed. So this is the job which you have to conduct. Alright. If polynomial value can be found out, there is something which you need to understand. We have one concept which is zeros of polynomial. When I say 2x plus 1, you need to find the value of x such that the value of polynomials come out to be 0. The polynomial value in this case was 5. If you put the value of 3, so 3 into 2 is 6, 6 plus 1 is 7, minus 3. So this is 3 into 2 is 6, minus 6 plus 1. So basically minus 5. We are getting different values of polynomial. But the value we need is 0. I should put the value of x in such manner that I get the value as a 0. So for that, what we need to do? This is a very easy way forward. One thing is you can hit and trial. You are placing different values of x, and one time you got the correct hit where you get the value of polynomial as 0. But a direct method says if you want the value to be 0, just put the expression equal to 0. What happens with this? When you put the expression equals to 0, in this scenario, you can find out the value of x for which this entire value, entire expression will become 0. So let's solve this one. So over here we have 2x equals to minus 1. I hope you know the transposition method, the balancing method, basically the solving of a simple linear equation. In this case, the final value of x will come out to be minus 1 by 2. And this value, when we put in the given expression of 2x plus 1, will give me the value of the polynomial as 0. Repeating once again, the value of the polynomial is simply by putting the value of variable. It can be different values, but we are interested in the value when it becomes 0. And when it becomes 0, what is the value of the given variable? What is the value of the given variable? That will be called as the 0 of the polynomial. 0 of the polynomial is that value of the variable for which we have got the value of the given polynomial as 0. How do we find it? We basically find it by putting the given expression equal to 0, and then we find the value of the variable. A very simple way forward. If you are interested in the definition part, here we have the definition. Definition in mathematics does not play any role, but if you are clear with the concept, then you will be able to understand the definition. It says the value of the polynomials for which the whole polynomial becomes 0 are called as the zeros of polynomial. So let me take one more example. 3x plus 3. I want to find out the 0 of this given polynomial. I'll equate it to 0. Equating it to 0 and solving for the value of x. So this becomes 3x equals to minus 3. And x from here comes out to be minus 1. When x value is minus 1, in that scenario we'll be having a 0 of the polynomial, value being 0. So this is the 0 of the polynomial. This value will be called as 0 of the polynomial. I hope you are getting the concept of zeros of the polynomial. Very simple concept. Alright. Now, on that concept, you need to solve few questions. Which of the following is the 0 of the polynomial 5 minus x? I hope just by seeing the expression you can give the answer. But otherwise, what's the method to solve? You have to equate it to 0. Find the value of x from here. X will be going on the other side, will become positive. Now, if I say 5 equal to x, or if I say x equal to 5, they both are the same thing. There is no difference at all. So over here, the value of x for which the given expression becomes 0 is the 0 of the polynomial, and hence we have the answer as 5. Understood? Very simple question. One more. Find the 0 of the polynomial 3x minus 9. What we need to do? We need to just equate it to 0. Solve for the value of x. 9 goes on the other side. It becomes positive 9 divided by 3. In one step, I have written over here. You even don't need to write. In the examination, you have to write. But when you have been asked simply orally, then you can do it orally as well. For the linear polynomials, it's very simple. The answer over here is x equals to 3. Very simple thing. Alright. Now we are coming to the part where we are going to talk about the polynomials as per se. What do they do? If I have to give an example of a polynomial, what example can I give? Sir, how does polynomial relate to our real life? If you are observant and if you are interested in cricket, I am very interested in cricket. These days I was observing some match of Ashes going on. Now, what happens in the matches? If you observe the matches, there is a ball tracking. What happens? Alright, the baller bowled the ball, it went something like this. Whether it was hitting the stumps or not, this is the thing, right? So whether it was hitting the off stump or the leg one or the middle, or it was altogether missing the stumps. Now, this ball tracking, how does this work? This is basically a curve. This is a curve. And when you have to write in mathematical term about this curve, you have to write a algebraic expression. Something of any sort. I'm not saying this is the one which will be resembling this one. But when you are writing a mathematical expression, this will be the mathematical expression for a curve. So it can work vice versa. If you are having algebraic expression or a polynomial as per se, you can always do the plotting. Plotting means plotting a graph of that given expression. And how does that plotting of the graph help? Plotting of the graph, as you have learned in data, is always a better way to understand things. If we have a graph of anything, when we observe cricket, there are many stats coming up. So if we say about the run rate, they show you a pie chart, or they show you the map scale, how does the batsman scoring run, on which side they're scoring most of the run. All these things, when we do the graphical observation, they are much helpful to us. So polynomial as per se are basically the equation of curve. If you have observed the mathematicians like John Nash, I hope you know John Nash, beautiful mind. If you don't know, you need to do a bit of research and understand few experts in the particular field which you are learning over here. So in most of the teachers which are highly qualified basically mean they are learning higher mathematics, which are doing the research. You'll observe the boards are filled with these variables and everything. Why? Because polynomial is the base foundation of all things. So end of the lecture, I might be deviating, so coming back to the part, how does this geographical meaning of zero of polynomial work? So when we do the plotting first of all, you need to understand there might be different kind of a curve coming up. A straight line can be there. A curve like this can come up. A zigzag curve can be like this. So multiple kind of curves can come up. What we are interested in when I'm talking about the geographical meaning, I'm interested in one thing. What is that? When you do the plotting of a graph, let me talk about a straight line. So if we have a straight line like this, I hope it is visible. In case it is not, I need to change the color of the pen so that it is more visible to you. I hope now it will be better visible. Now, what happens in this case? This given line basically is a curve of a given equation, right? Or a polynomial. In this, somewhere it will be intersecting the x-axis. Wherever it is intersecting the x-axis, that point is representing the zero of the polynomial. It is representing the zero of the polynomial. If the line is cutting the x-axis at one point, I'll say only one zero exists. If the line is cutting at two different points, I'll say two zeros exist. If the line is cutting at three different points, I'll say three zero exist. For a linear polynomial, we generally have a straight line. We will always do the plotting and we'll find a straight line. And straight line will be cutting at only one point. It's not that line can be bent like this and it can cut at different points. No, the only possibility is that it might cut at one point. For a quadratic, the graph would be very different, which I'll be talking in detail in the upcoming time. For quadratic, it will be a curve. So that curve might intersect at 2 points. For the cube, it might intersect at 3 points. The concept which needs to be learned over here is that the number of points where x-axis have been intersected or been touched, that represents the zero. This is the concept about the geographical meaning, not geographical, what happens to me. Geometric meaning of the zero of the polynomial. Alright. Geometry, geography, basically related latitude, longitude, all these things. The curve part, I hope you understand. Alright, so on that note, we need to move on. And once again telling you, if you have a curve like this, and someone asks you just by observing the curve, how many zeros of the given polynomial? See, you can easily tell. 1, 2, 3, 4. Why? Because at 4 different points, the x-axis has been intersected. At 4 different points, x-axis has been intersected. So hence, the number of zeros in this case will be equal to 4. Just by observing the graph, you can tell. So now, let us do this understanding and find out the answer for the given question. The graph of a polynomial px cut the x-axis at 3 points. At 3 points, it is cutting the x-axis. Is that all? Let's see. And it touches at 2 other points. Touches. So touches and intersecting is a different thing. How? If I talk about a graph, this is the graph. So something it is cutting at 3 different points. So let's say over here 1, 2, 3. Here 1, 2, 3. 3 points it has already cut. At 3 different points, it has cut the x-axis. 1, 2, 3. Fine. Now, and it touches at 2 other points. What does it mean by touches? Touches simply over here is like this. Now, what happened? It goes like this, but simply touched. It didn't intersect it as such that on the other side it reached. No, it simply touched it. And again, it will be repeating the same operation like this. Now, we have 2 different points where it is reaching out to the x-axis. This is another point, this is another point. I told you. It's not only about the intersecting, it's also about the touching. Either intersect or touch. Basically, there is a point of contact with x-axis. So the point of contact with x-axis is at 1, 2, 3, 4, 5 points. So the number of zeros they are asking, the number of zeros in this case, will be simply 5. Answer will be 5. So this is the concept which you need to understand for the geometric meaning of zeros. The next question you will be answering very quickly. We have to find the number of zeros by observing the graph. Once we have answered the previous question, this is not a difficult one. You can see 1, 2, 3. 3 points where it is intersecting. Find the number of zeros of non-negative zeros. Now, here is the trick. The question will not always be straightforward. There will be something which you need to observe. Number of non-negative, which are not negative. So basically the value of x should not be negative in that scenario. So when you observe the graph over here, so what happens? We are having 3 points of intersection. 1, 2, 3. Now, this intersection is having a positive x value. I hope you understand the Cartesian plane. Over here we have the value of x is positive. Over here the value is 0. And over here it is a negative value. Negative value, positive value, 0. All the cases are there. What we need to find? We need to find non-negative. 0 is a non-negative thing. It works for us. So only thing which will be going out of this is this part over here, the negative part. We want non-negative. 0 will work because it is not negative. So the answer in this case will be the number of zeros are 2. That's the answer. By observing and not reading carefully, you might have saying that 3 zeros were possible. And that would have been the wrong answer. I am telling you, this is the manner you need to answer. Read the questions very carefully. Each and every word in the question is very, very important. Alright, so that was all about the geometric meaning. I'll come back to the geometry of the polynomials, but first talk about the quadratic polynomial. In quadratic polynomial, first thing we need to understand is about what are quadratic. I hope you can now describe me what are quadratic, because we have already talked about the polynomials having the highest degree as 2. They will be quadratic polynomial. So this over here, or 4x square minus 4, or simply 4y square. All these are quadratic polynomial. Why? The highest power of the variable needs to be observed, and the highest power in all the 3 cases are 2. Alright, so if we have the degree as 2, we have quadratic polynomials. This is the simple thing. In quadratic polynomial, if you observe the general way of writing it, is this one. This is called as a general form of a quadratic polynomial. General form? Yes, general form. You have learned in biology. We are Homo sapiens. We are Homo sapiens. Sapiens is basically our species. There are other species of this as well. Homo erectus. Right? So we have different creatures which are coming under the same species. This is the general form. This describes all the quadratic equation. All the quadratic equation can be represented in this form. Why are we interested in this? Because we are going to talk about the relation between the given coefficients over here and the zeros of the quadratic polynomial. Alright, so on that note, we need to go forward and understand about how we are going to find the factors, or basically over here I am interested in zeros of polynomial. Zeros for the linear part, I hope you remember, I told you need to equate to 0. 3x plus 2. I told you if you need to find the 0, you need to equate it to 0. You'll equate it to 0 like this, and you'll find the value of x. And that will be the 0 of the given polynomial. But the things are not that simple in quadratic. Now the level of the game is up. You cannot easily go forward just by this method. So when you have been asked about a 0 of the given polynomial over here, x square plus 13x plus 30. Now if you put up this equal to 0, x square plus 13x plus 30 equal to 0. This will not work for you, because in this scenario, you cannot directly find the value of x. There is a way, always there is a way. What is that way? The way over here will be to factorize this given expression. Factorize. If you remember, we have learned about the factorization method. Factorization can be done by splitting the middle term. If you don't know, now's the time you know how. So for the given part over here, for doing the factorization of this part, you need to observe the constant value, and you need to observe the coefficient of x square. You need to multiply both. 30 being multiplied with 1. Ultimately what we are getting? We are getting 30 over here. So the constant value being multiplied with the coefficient of x square, you have to factorize that number. Factorizing 30. So 30 can be factorized. 3, we are going for 10. So this is 5 and this is 2. 3, 5 and 2, these are the factors. Once you have the factors, you have to make an arrangement. What kind of arrangement? The factors when added, we get 13. The factors when multiplied give us the value as 30. Middle term by getting the addition of the two factors, and the constant value by multiplying. So if you observe, we have 3, 5, 2. So if I say 5 into 2 is 10. 10 and 3. 30 can be written as 3 into 10. And 13 can be written as 3 plus 10. Now this is what you have to do for the splitting the middle term. For splitting the middle term, I can write now the given expression over here as x square plus 3x plus 10x plus 30. Once we have splitted the middle term, now you have to do the clubbing and taking out common. Taking x common, this is x plus 3. Taking 10 common, this is x plus 3. And we have the same term x plus 3. We can write it as x plus 10 into x plus 3. Sorry. I hope you are understanding what I have done. I have done the factorization, nothing new. We have already learned the factorization. But when I say factorization, now what happened? You remember equating it to 0. Now we can go back to the basics of the method, that equate it to 0. When you equate this given expression equal to 0, so either this part, that is a, will be equal to 0, or this part equal to 0. Basically, when we are multiplying two terms and we are getting product as 0, either of them will be 0. In that case, it is possible. So I will equate this part as 0 or this part is 0. Whatever the value of x I'll be getting, that will be the answer. When we equate this part to 0, I'll get x value as minus 10. When I go for this one, this is minus 10, not 16. Minus 10 over here. When I equate this part as 0, I'll get the value of x as minus 3. So, which will be the answer? Both will be the answer. For quadratic polynomial, we'll be having two zeros. In linear, we were having only one value of x, which was giving the answer. But in case of quadratic, we'll be having two values of x, for which we'll be having the correct answer. So, the zeros of the given quadratic polynomials are here. And once again, reiterating the fact that for finding the zeros of quadratic polynomial, you have to factorize, split the middle term. So if you don't know the splitting of middle term, here's a general method, but it will not work. This is not something which you can note down and solve. Why? Because if you are practicing the method by taking up the given expression only, then you will learn. But ultimately what we need to do, middle term should be written in the manner that the factors when added get the same part as the middle term. And we have the product of the coefficient of x square with a constant, and the factor should be multiplied in this form. Alright, this is about the factorization part. Now, if you have to find the zero of the given polynomial over here, the only method I have told you, by splitting the middle term. So, split the middle term for this given part. What we need to do? First step, multiply with the product, multiply the coefficient of x square. Over here it is a square with 24. 24, do the factors in such a manner we can get the addition as 10 and the product as 24. So 24 can be written in what manner? You can do the factorization. 2, here we get 12. 2, here we get 6. Again factorizing, here we get 3. Now we can observe what we need to do for 24. What do you think? What can be done? 2 into 2 is 4. 4 into 6. 4 into 6. Why 6? 3 into 2 is 6 and 2 into 2 is 4. I am doing the clubbing of this and clubbing of this. 6 plus 4. So 4 into 6 equals to 24, and 4 plus 6 will be equal to 10. This is how you need to factorize, and I'll leave the question over here for you to solve, because everything cannot be solved for you. Something needs to be solved from your end so as to make sure that you have learned. So you need to find the zeros, and I hope you can realize the factors from here. 6 and 4 are for sure, but the signs are important. Make sure you find the correct sign and the correct answer. I'll move on and solve one interesting question related to the zero of a quadratic polynomial. Read it carefully. If one of the zero of a quadratic polynomial x square plus 3x plus k is equals to 2, x square plus 3x plus k. Over here one unknown is there. However, there is an unknown. We have a variable, but we are not interested in the variable. We are interested in the unknown, which is k over here. They say that one of the zero, there are two zeros in case of quadratic polynomial. So one of the zero is given to me as 2. If one of the zero is given to me as 2, so basically it means if I put the value of x as 2, what will happen with the given expression? If I put up the value, that means the zero of the given variable, what will happen? The entire expression will be equal to 0. This will be equal to 0 if I put the value of x as 2. So what are you waiting for? Put the value of x as 2. So over here 2 square is 4 plus 3 into 2 is 6 plus k equal to 0. From here you can find out the value of k as simply minus 10. That's it. A very simple method. You have to observe the given expression, equate the value which has been given to you as a 0. X, the one of the 0 is given to you as 2, so you put the value of x as 2. Once you put the value, x as 2 is 2 square is 4, 3 into 2 is 6, 4 plus 6 is 10, x, sorry, not x over here, k equals to minus 10. This is your final answer. A different question related to the zeros. This can be asked. There are plethora of questions which can be asked. Alright. Now, one final thing I want to talk about in the quadratic part, and that is the geographical representation. Again, see, geographical. It's not geographical, it's geometric representation. In geometrical expression over here, representation over here, we are having three cases. What are the three cases? Now, first thing is you need to understand what kind of a representation would be there. If I talk about plotting of a quadratic polynomial, we will be plotting, so it will be coming out like this curve, and this curve is called as parabola. This is one case. What kind of a case is this? Over here we observe we are having 2 points. We are having 2 points where we are having the intersection. These are the 2 points where we are having the intersection. In both the cases, either it is upward or downward. In both the cases, we are having intersection at 2 points. In the second case, what will be having? We will be having only one part where it will be touching. Like this. So wherever is it touching, that is the 0. So over here, this is our 0. So over here, sir, it is touching at 1 point. So it basically means that the quadratic polynomial is having only 1 0. No, that's not the case. When it is touching, that means we are having 2 equal zeros. This we'll learn in much more detail going forward. One final case over here. What do you observe now? Ignore my drawing part, ignore my bad drawing skills, but what do you observe? You might observe the part that it is not intersecting at any point on x-axis. When it is not intersecting at any point on x-axis, the one thing is for sure, and that thing is that we are not having any 0 over here. So basically no 0. There will be a 0, but it will not be a real 0. What does that mean? I must have told you about the numbers which are not real. So we'll talk about it in the next grade when we reach up to it. But for your understanding, make sure that they are not having any real 0 over here. These were the 3 cases, and related to these 3 cases, let's first quickly solve this question given over here. A real number a is called a 0 of the polynomial fx. If you remember, I told you p of x. I told you about p of x. P of x simply means polynomial with the variable x. So when they say a real number a is called as the 0 of the polynomial f of x. Again the same thing, polynomial with the variable x. So if a is the 0, so basically I am replacing the value of a with x with a. In this case, what will be the value of the given polynomial? If you remember, the value of the polynomial I told you is 0. If the value becomes 0, in that case it will be the 0. So if I put up the value of x as a, it will be giving me what? It will be giving me 0. Right? So the real number a is called as the 0 of the polynomial. Then in that case, if I say f of a equal to 0, why? Because for this value, that value of a, the entire expression will be reduced to 0. This is the point which I need to understand, a very, very simple and basic thing. I hope we are understanding this part. If we are understanding this part, now we are reaching to the final ultimate thing of this chapter, which is the relation between the two. Over here. Now, in the given expression over here, if I ask you to find the 0, what will you be doing? I hope you remember splitting the middle term. 10 is having a factor of 5 and 2. So 5 into 2 is 10, 5 plus 2 is 7. So I'll rewrite it as x square plus 5x plus 2x plus 10. And I'll do the clubbing, find out the common part. X plus 5 plus Taking 2 common, again x plus 5. Finally, we have the factors as x plus 2 into x plus 5. What are the zeros? Zeros is nothing but equating this part equal to 0. X value comes out to be minus 2. And in this case, equating to 0, x plus 5 equal to 0, x being equal to minus 5. These are our 2 zeros. These are our 2 zeros. Now, in this scenario, observe the 2 zeros. Minus 2, minus 5. Minus 2, minus 5. What I can do over here? If I say 0 is alpha, another 0 is beta. 2 zeros being alpha and beta. I can do the addition of the 2 zeros, alpha plus beta. Alpha in this case was minus 2, and beta in this case is minus 5. So alpha and beta, don't get concerned about alpha and beta. Alpha and beta is just the representation of 0. We are using some fancy notation so that you don't feel bored over here. We are having some fancy pronunciation in mathematics as well. Alpha plus beta is simply the addition. So minus 2 plus minus 5. This is minus 5. This is minus 7 over here. I can do the product of it. That means multiplication. Minus 2 into minus 5. It will be giving me as equal to 10. So, but why are we doing it? Now, the reason I am doing it, if you observe the given expression, over here, we are having 7 over here, we are having 10 over here. When I do the operation of addition and when I do the operation of multiplication, I have come up with same things. I have come up with very similar things. Only the sign difference is there. So basically there is a relation between the zeros and the coefficient, and this relation happens when we do the addition and the product of the zeros. Again saying that alpha and beta are just the notation of zeros. They are not the zeros itself, they are the notations. We are using them to represent the zeros of the polynomial. So when we are doing the addition and we are doing the multiplication, what happens? We are getting a relation something like this. And what is the relation? If we do the sum of the zeros, we have assumed alpha and beta to be the zeros. So when we do the addition, we get the value as minus b by a. What is minus b by a? If you remember, I gave you the general form. This was the reason I gave you the general form. Ax square plus bx plus c. This is the general form. Here we have a as the coefficient of x square, b as the coefficient of x, and c as the constant value. Now, in this case, minus b by a. Ignore the first negative sign. Talk about b by a. B is the coefficient of x, a is the coefficient of x square. So, coefficient of x divided by coefficient of x square with a negative sign multiplied along with it. So, when you observe over here, minus 7, and that is the reason we have to put one more negative sign, and hence it will become positive over here. Plus 7x. Similarly, when you do the multiplication alpha and beta, we are getting c by a, constant term divided by the coefficient of x square. A very, very important, and the most majority of the question are asked from this concept in this chapter. And going forward, if you are opting mathematics for the grade 11th and 12th, you will be definitely going forward with these formulas and have to solve complex questions related to it. So better you take a screenshot, or better you note it down and start solving few questions on it. I hope you have understood it. The relation is simply between the coefficients and the addition and the multiplication of zeros. The better way always to learn in mathematics is not by mugging up, by solving questions. But before that, I want to give some extra information, something additional getting. So a fun fact, you can take it as a fun fact. This will not be used at this grade, to be very honest, but you can note it down because this is also a relation between alpha, beta and gamma. What is gamma, sir? Gamma comes when we are dealing with a quadratic, not quadratic, cubic polynomial. In case of cubic polynomial, the degree is 3. When we have degree as 3, what happens? The polynomial zeros will be 3. And the 3 polynomial zeros will be alpha, beta and gamma. When we do the addition, we get b by a. When we do the product along with addition, we get c by a. And simply doing the product will give me minus d by a. Take a screenshot of it. Again telling you, the question will not be asked using this particular part over here. We are interested in only quadratic polynomial. So let's solve some question quadratic polynomial. Very, very important and very good questions these are. So make sure that you are attentive in the last 10 to 15 minutes of this session. Alright, that's a humble request to you. Write the sum and the product of the zeros of polynomial with a variable x. That is x square plus 12x plus 11. What we need to do? We need to find the sum and the product of the zeros. Now, a student who hasn't learned the last concept which we have talked about, what he'll be doing? He'll be doing the factorization, he'll be doing for the splitting the middle term, and whatever zeros he is finding, he'll do the sum of it and he'll do the multiplication of it. But that's not the way forward for this question. This question needs just hardly 2 to 3 seconds. Why? We have just now learned that the sum, that is alpha plus beta, sum is what? Minus b by a. The product alpha into beta is c by a. If you observe the given equation, compare it with ax square plus bx plus c. In that case, the value of a over here is simply 1, the value of b over here is simply 12, and the value of c over here is simply 11. Now, putting up in the alpha plus beta part and alpha into beta part. So minus b by a. Minus sign will always remain. B is 12. A is 1. So minus 12. C is 11. 11 by 1 again 11. So minus 12 is the sum. 11 is the product, and that is what they are asking. I have taken much time to explain you and writing on the board, but that was not required just by seeing it. Acha, 12 over here, so negative sign will be involved, minus 12. 11 will go as it is because the coefficient of x square is 1. The correct answer, minus 12 and 11, option number C. That is how quickly you can answer if you know the relation between the zeros and the coefficient. This was the question just to explain directly how we can find. Next question, find the sum and the product of zeros. Again, same thing repeated. Now I hope this time you can answer on your own very quickly. The only change this time is we are having the coefficient of x square. This time we are having the value of a as 2, b as minus 3 and c as 3. Minus b by a. So minus sign will remain as it is, but this time we are having the value of b also minus. So minus 3 upon a. A is 2. C by a. C by a. Over here in this case c is 3. So 3 by 2. Minus minus. Minus minus become positive. So positive 3 by 2. Positive 3 by 2. Both the sum and the product. Sum and the product are positive. Hence answer is option number C. Very simple task. I told you the most important concept of this chapter, but that doesn't mean most difficult. One of the very easiest things if you have understood the concept. Alright, next question. A quadratic polynomial, that is what we are learning, whose sum and the products of the zeros are 0 and 5. Always read the question carefully. Always read the question carefully. This time they have given you the sum and the product. Now, what are they asking you? They are asking you the given equation, the expression for the given part over here. The sum is given, the product is given. For the sum, you know, this is minus b by a. For the product, you know, this is c by a. From here, you can get the values of a, b and c. When we are having this value of 0, minus b by a, it's not possible that the value of a becomes 0. There are two reasons behind it. First reason is 0 cannot be in the numerator. I hope you remember the concept in rational number. We cannot have 0 in the denominator. So definitely a will not be having 0, but b will be equal to 0 from here. Another way you could have understood this part, they are talking about a quadratic polynomial. If the value of a becomes 0, x square will not exist, only x will exist. In that case, what happens? In that case, it will not be quadratic polynomial anymore, and that contradicts the question. No one wants the contradiction in the question because the examiner is having a credibility to give you the best question available, right? Now, so value of b is 0. What about this c by a? In this scenario, you can observe that a would have been 1. So in this case, the value of c can be taken as simply 5. Compare over here. Compare over here. We are having x square. Why? Because the coefficient of x square, that is a, is 1. We are having the value of b as 0. That means there will be no plus bx. That will be reaching to c. And c in this case is 5. So x square plus 5. Our final answer. The term bx over here is simply cancelled out as 0. The value of that is 0. This is a quadratic polynomial. Don't think that this is not a quadratic polynomial. This is having 2 terms, not 3. The reason being the bx part is missing. If ax square part have been 0, it will not be a quadratic polynomial. basic conceptual clarity. That is all I am talking about in the entire expression. Alright, one final question let us take. The question on its own is of very high level. You might think, sir, this is not something which we are talking about, because we are talking about simply alpha plus beta, alpha into beta. Why are you talking about the reciprocal addition? The question on its own is complex, but that doesn't mean that you will give it up. Always give your best try to it. 1 upon alpha plus 1 upon beta. This value you need to find. Again, when you have such kind of expression where you have no clue, the basic works. So most of the students will go forward to find the value of alpha and beta. In the given expression, they'll try to find the value of the zeros and then put up the values and try to find out. Again, a very lengthy method. You are playing a test match when you have to play a T20 game. So there is a difference between the two. The approach should be very different. So the approach in this case is rather going to find out the value of alpha and beta, simplify the given expression. If we have been given in this form, always simplify. When you simplify, you have to take the LCM. I hope you understand how to take the LCM. Two numbers are there. If you don't know what will be the LCM, always do the product of them. When you do the product, the addition, the numerator will come out to be what? Alpha plus beta. Now this is very simple to answer, because alpha plus beta I can answer and alpha into beta I can answer. Alpha plus beta is minus b by a, minus b by a. Going by the given expression, value is minus 1 by 1. Going by the product c by a, we have c value is also 1 and the a value is also 1. So this is 1, this is minus 1. From here I can put the values of alpha plus beta. I have found out this value over here. I found out this value. This value is minus 1. This value is 1. So putting up the values simply over here. This is alpha plus beta as minus 1 upon 1. This can be simply quoted as 1. The answer 1. I have taken so much time just to write on the board. But for you, that will not be the case. You will immediately read it. You will see the simplification, alpha plus beta upon alpha into beta. Answer would be option number B. That quick you can be. That is the way going forward. So I hope you have understood each and every concept over here. Now I might have taken a lot of time to do the summary part, but I hope you realize I have emphasized more on the basics of this chapter. Because if the basics are not covered, nothing will work for you. You might end up mugging up a lot of formula, but that's not any use to you. So the concepts are done. Few questions were done, but few will not work for you. The working part will be how much practice, how much effort you put forward to it. I am telling you once again, this is a very foundation chapter and an important chapter for grade 11th and 12th. So make sure that you practice well, revise well, work well and enjoy well. Have a great time, enjoy yourself. Hope for the best of health of yours. Always do the practice, always do the study part, always do the playing part and be happy. That's all from my end. So have a great time. Bye bye everyone.